director.
Okay, let's talk about these building blocks. So tonight we'll cover global infrastructure. This is mostly owned by AWS, and then you interface with it through the console or the CLI. Then we'll cover networking. Obviously, that's the crux of what we're doing. And then just a little bit, we'll cover compute. This kind of talks about the building blocks we'll be doing tonight. Other key building blocks would be storage, security. We touched just the tiniest bit on security, but not enough that I felt it deserved to be in the outline. And then there's all the different application services, and there's dozens, if not hundreds of these in AWS. And then there's all the deployment and administration tools as well, right? None of those we're going to cover tonight, but these three key building blocks, global infrastructure, networking, and compute, will cover security just a tiny bit. So let's dive right in with global infrastructure. And so we're really talking about three things. We're going to focus on two of those three things tonight. But the three components to global infrastructure are really regions, availability zones, and edge locations. I'll deal with edge locations first, simply because we're not going to cover those really in the bulk of the content tonight. This is a content delivery network. Kind of think of it as regional POPs that are all over the world potentially. And there's hundreds of them actually currently, or at least last count I had was over 200 of them. And they're used for local access to store and cache content, right? So if you have an app and it has some kind of static content, you can pre-cache that down at your CloudFront CDN or something like that. The number one top level thing for global infrastructure is regions, which is really just a geographic area with full AWS presence, right? That means a minimum of 2 availability zones, but almost always it's 3 availability zones or more. There's only a couple of regions that have 2 availability zones. And there's 21 of them currently that I'm aware of. That does not include some of the regions that may be specific just to government clients, like what they call GovCloud. So when you think of region, you want to think of covering an entire geography. So everything we're doing in the demo will be done in Oregon, which is the US West 2 region. The next item is availability zones. And you really want to think of an availability zone as one or more data centers within a region, right? So the region's the top level construct. The region contains availability zones. Availability zones are effectively data centers. It could be a single data center, or it could be a cluster of data centers that make up a single availability zone. And as mentioned, there's always a minimum of 2, but often 3, 4, 5, 6, up to 6 availability zones in a given region. There's roughly around 70 AZs currently across those 21 regions. So, and this is important because we'll be talking about the scope of certain objects. And you want to know, is an object scoped at the region level, which means it covers all availability zones within a region? Or is the object scoped at the availability zone level, which means it only covers a single data center, right? Okay, so probably the most fundamental thing when it comes to networking would be the VPC, which stands for Virtual Private Cloud. And the VPC is a regional construct, right? So when you build a VPC, it automatically is spread across all the availability zones that are in that region, right? So the VPC can automatically reach all AZs. Whether you configure anything in those AZs is a different matter altogether, but it has access to all the AZs within the region it's created in. There is something called a default VPC. It can be helpful when you're just trying to get used to things, but I see it rarely used in production. You can even delete the default VPC these days because they added the capability to recreate it. I tend to, there's absolutely no technical analogy here, but I tend to think of The default VPC, kind of like VLAN 1. It's there, leave it alone, but don't put anything in it, okay? When you go to create the VPC, really all you need is a CIDR block. You have to have an IPv4 CIDR block, and you can have also an IPv6 CIDR block. There are some caveats with the IPv6. The CIDR block could range anywhere from a /16 to a /28. Spoiler alert, do not use a /28 unless you're maybe just playing around and getting used to things. You can have secondary CIDR blocks. You can have, I believe, up to 4 CIDR blocks currently on a VPC, but it's always one primary and everything else is secondary. And that secondary is that primary can never be edited. Whatever CIDR block you put in there, it's in there forever. We had a quick question here. Is there value to be gained here that maybe a lot of people don't take advantage of? I'm not sure. Do you mean on creating a VPC in general? You have to create a VPC because that's where all your things are going to go.
No, I was kind of referring to the regional space of things. For those of us who haven't had to deal with this before,
Oh,
I'm
yeah,
sure that there are places where you can gloss over things and just move in and become functional. And,
yep,
but it's very likely that the people who really know what the hell they're doing here go, oh, no, 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 you should, for a region where
got it.
you've got a whole bunch of
Okay,
spots, this is something to take advantage of that maybe some people don't do when they're bringing up their stuff.
yep, yep. Okay, so we were actually going to cover that in the very next slide, but real quick, um, the multi-availability zones within the region, that's going to be one of your main ways of providing redundancy. Because remember that an AZ is really a physical data center. It's got its own power, its own cooling, its own network connections in and out, all those sorts of things. So when you span your resources redundantly across multiple AZs, it's like spanning them across multiple data centers. And so it's a key fundamental building block in terms of resiliency for your applications and your infrastructure. So it's a good question. And you want to think of the availability zones as being unique subnets, right? So each availability zone will be a unique subnet. You could have multiple subnets in an availability zone, but you typically want a minimum of 2, and then up to however many AZs you actually need. I tend to usually either go with 2 or 4, mostly because it makes my subnetting a lot easier. 2 and 4 are both powers of 2, so subnet boundaries are really easy. You could do 3 or 5 or 6, depending on the region. You're somewhat limited based on the AZs that are available for the region, but every region will have a minimum of 2. Most will have 3. So it gets a little into the weeds from there, Charlie, but does that kind of answer your question?
Exactly. That,
Okay, perfect.
that's the kind of thing that I'd be looking for. Yeah. Thank you.
Yep. And one thing, this is kind of an important concept. Every single VPC that you spin up, it has something called an intrinsic router. It's just a router that's built into the VPC. You have limited influence over that router. You can add routes to it and you can take routes out from it, but you can't, it's not a router like a Cisco router or something. It's got a lot of differences. It's more like a routing service. For example, it has an absolute hard cap maximum of 100 routes in the routing table. And there are some routes you're not allowed to remove from the intrinsic router. So this intrinsic router becomes kind of a key fundamental thing. And when you're planning out your VPCs, you really want to do your IP addressing up front and think about how big do I want my regions? How large do I want my VPCs? Because remember that primary CIDR block, it's not editable. So for example, in my picture here, I have 10.1.0.0/23. I cannot edit that. I can't grow it or shrink it. So I want to be a little careful on how I number it, right? Um, so if, for example, I know that I'm going to start with hundreds of servers, but I am hoping that things take off and I may go to thousands of servers, then I definitely want something larger than a /23. If this is just a little test environment that I'm just playing around with, this is a lot of wasted IP space probably, right? So just keep that in mind. Oops.
Reason, what would be a reason you would not use VPC in production?
I'm sorry, what would be a reason for what in production?
VPC in production.
Boy, that was very faint. For some reason, it was.
Oh, it's better.
Oh, that's better. That's better, I think.
Yeah. And what would be a reason that you would not use a VPC in production? That's your second bullet point there on the right-hand side.
So that's kind of a typo I'd mentioned before. That's actually referring to the default VPC. And you'll see when we go into the demo, I'm going to create my own VPC. I don't use the default VPC. Most people rarely use the default VPC in production. When you create your AWS account, AWS automatically creates a VPC for you in every single region in the world. You're not charged for any of that. They just kind of create it. And it's a default VPC because it's got a bunch of default things built. And the idea is you could go in there and just start deploying stuff. Unfortunately, it makes it not very useful because they all have overlapping IP space, so you can't interconnect them with one another. Um, and uh, uh, and the IP space is not changeable, so you got to use uh, I think it's 172.31.0.0/16. Um, and it's kind of very vanilla and generic. So it's just a typo. I forgot to put default VPC is helpful in sandboxes, but rarely used in production. So yeah, thank you. Charlie asked, is there a best practices recommendation? So my best practice recommendation here is probably don't use the default VPC. You want to be sure that you plan your IP space accordingly. What accordingly means really depends on your specific use case. Um, you don't want to pick a CIDR block that's so narrow that you can't expand later. You don't want to pick a CIDR block so large that we could never fill up that address space or something like that.
Might there be some examples of existing customers or organizations that have created this and found that they either hit a limitation or that they sized it correctly or they
So
overpriced?
So the problem there, Charlie, is every company is incredibly different. I have some customers that have all their infrastructure in AWS, and they need to size things very differently from companies that are maybe just getting started, right? And I should say, again, this is a very introductory topic. Um, so like we're only on slide 2 here, and we're already quite a bit in, but it's difficult to give super generic best practices. The best practices I would recommend at the VPC level, again, is don't use the default VPC and try to plan your CIDR block accordingly. If you have no AWS experience, I would recommend working with some kind of consultant to kind of help you get your feet wet. And at the very end, by the way, I do have some general best practice recommendations for just getting started with AWS, not necessarily specific just to networking. That includes some hyperlinks. So you'll see those at the end as well.
Okay, yeah, it's one of those where, case studies are helpful, even failed case
So
studies, because at least you learn something. And I'm sorry for tying you up so much in the early slides.
yeah,
It's
it's okay.
one of those where when you bring in a consultant, they're still going to be asking you questions that you're going to want to answer, out of
100,
this
yeah,
kind of space.
100%. So I totally agree with that statement, right? The problem is, I don't know, I have probably a dozen customers I work with in AWS. None of them are very universally alike because they're doing very, very different things, right? Like I said, I've got one customer, they have 0 data centers. They're 100% cloud-based. They're also 100% automated. It's all DevOps, right? That's an incredibly different use case and an incredibly different architecture than a more monolithic, we're going to move some apps up into the cloud. And I would rather, I'm still going to do things through the console, like I'm going to do my demo tonight. So there's a lot of nuance I just can't easily cover. But those are great questions, Charlie. You're right on the money there. Okay, let's talk about the next one, which is the subnet. So I've built my VPC. I've added in a CIDR block. But I need to take that CIDR block and break it into subnets so that I can actually start building things. The subnet, so that remember that the VPC is a regional construct. The subnet is an availability zone level construct, right? So that's what I was saying earlier, that you want to think of the availability zone as being tied to a subnet, right? So when I create a subnet, here I've created 2 of them, 10.1.0.0/24 and 10.1.1.0/24. This subnet can only live in a single AZ, and this subnet can only live in a single AZ. And that means, remember that an AZ is really just a data center, right? And that means that a night, and this kind of ties back to what you were saying or asking earlier, Charlie, is one of my key factors in resiliency in AWS is to build things across availability zones, okay? Because that way, if there's ever an outage in this data center, I can hopefully still have resources up over here in this data center. And there's, depending on your app, there can be a lot of different ways to do that. I can't really give you a recommendation because it's very app specific. It is a layer 3. There's no way to do layer 2 between these. Maybe I shouldn't say no way, but no easy or reasonable way to do layer 2 between these. It depends a lot on the type of app, how you maybe want to do that kind of failover. There's a couple of different ways that are kind of more commonly done with load balancers that front end the different AZs and send the traffic across. Um, the other thing to be aware of is, and I mentioned this in the first slide, but that intrinsic router, it automatically is directly attached to every availability zone that you configure a subnet in. I'm sorry, was there a question? Oh,
So,
someone I think came off mute and I'm getting some feedback. Maybe if everyone.
yeah,
Okay,
I got it.
that's
I
fine.
got it. I took care of it.
Thank you. Okay, so just be aware that there's no way to not have the intrinsic router directly attached to a subnet when you create it. But the intrinsic router is really only connected to the subnets you create. So if there's 3 AZs, but I only create 2 subnets in AZ1 and AZ2, for example, there's nothing to connect to in AZ3. The intrinsic router is actually still over in AZ3. It just doesn't have anything to connect to, right? So when you create the subnets, you just need to know your VPC identifier so that you know where to create those subnets in. And you just need to remember that the subnets need to be subnetted out of the CIDR block that you associated with the VPC. If you have secondary CIDR blocks, then you could pull a subnet off of the primary or any of the secondaries, right? So you have a couple of options there. These subnets, they can range anywhere from a /16 to a /28. That means I could take an entire CIDR block and put it in a single AZ. That would probably not be a good idea. You almost always want to take your CIDR block and build it across multiple AZs. I like to do 2 or 4 because again, it makes the subnetting math a lot easier because it's a power of 2. But you have some different options. Okay, the next thing that we're gonna, next thing we're gonna cover is the internet gateway. So now I've created my VPC, and that's a regional construct. And then I've created my subnets, and that's an AZ level construct. And now I may want to get to and from the internet. And so I'm going to create something called an internet gateway or an IGW. By the way, until I create a gateway like that, like an internet gateway, there's a couple other gateway types. My VPC is it truly is private. So it's like a private data center. I've basically created nothing that can route in and out of the VPC. And so anything I build is truly private under what's in that VPC. That also makes it not terribly usable because I can't easily log in and do things with what I've built, right? There are some exceptions. We're not going to go through those tonight, but by and large, you need to put some kind of gateway object. The most common gateway object in AWS is the IGW. We will talk about a couple of other gateway objects in the advanced section. So the IGW is a VPC level construct. That means it spans the entire region. It spans all the availability zones within a region, right? It also means, by the way, that it's highly resilient across all AZs because the IGW is in all AZs. You're going to create the IGW. The only thing you need to create it is you need to know what VPC it's going to be affiliated with, because after you create it, you're going to need to attach it to that VPC. You'll see that when we create it in the demo as well. And while it does provide access to the AWS public backbone, it's also a high-speed NAT device. Of course, you cannot get to and from the internet without NATs. And so we do have to have some kind of NAT mechanism, and we're going to talk about different NAT mechanisms coming up. The IGW is auto-scaling when it comes to bandwidth. There is a limitation that a single session can only go at 5 gigabits per second, but there's no limit that I'm aware of on the number of sessions that you could have. I think a session is defined as a 4-tuple in AWS, but don't quote me on that. I think it goes by source destination IP, source destination port. So, but it's an auto scale thing on the IGW. You don't need to do anything to scale it up or down. And so now I've created my IGW. Well, I need to actually do some routing at some point, which means I need to have some routes in this intrinsic router. So I'm going to create a route table. Now, a route table, there are 2 types of route tables effectively. And the route table's a VPC level construct. That means it can tie to all the AZs that are within the VPC, right? There's main routing tables, and then there's non-main routing tables, for lack of another word. Basically, it could be main or it could not be main. I do not care much for the main routing table, but let me explain what the main routing table actually does. When you create a routing table, and we'll see this in the demo, you have the option to explicitly associate one of these subnets with the routing table. Any subnet that is not explicitly associated with a routing table is implicitly associated with the main routing table. So a lot of people, and I've talked to AWS about this, I don't know if this is their current best practice, it used to be a best practice for them, is don't use the main routing table. Instead, always explicitly associate your subnets with the routing table you want them attached to. Because you have the capability of creating multiple routing tables within your VPC. You can have many routing tables. They all aggregate up to this intrinsic router. And as I mentioned before, there is a 100 route limit on the intrinsic router. So you don't want to go too crazy with the number of routes you program in there, because 100 routes is not very many. But there's a slightly more advanced use case of what they call public and private networks, where you would have two route tables, for example, that point to different things in different ways. Probably a little outside of tonight's scope, but it's not an uncommon architecture if you kind of just go look around a little bit. One thing to be aware of the route table is it will always contain the VPC CIDR block as a local route. That's something you cannot change. So whatever CIDR block or CIDR blocks, if you have more than one, are associated with your VPC, they're automatically in every route table in the VPC as local, and you cannot change that. You cannot filter that. So remember I said that we have limited influence over the intrinsic router. This is an example of that, right? If you're used to Cisco routing, of course, you're used to, hey, I could do things like block a route from propagating even if it's local. You can't do that with an intrinsic router, not on the intrinsic router. You could do it with some other third-party routing device. Like I've got an account that uses Cisco CSRs, and we do those blocks via BGP because it will auto-propagate any locally attached CIDR blocks effectively. And you might not want to route those for different reasons. And when and we'll see this, when you program your routes in the routing table, they look a lot like a static route on a iOS router. You're just going to put in your destination network and your next hop. It's just that your next hop will be an object, not an IP address.
Jason,
Someone
this
have a
is
question?
Guillermo. Yeah, Jason,
Yeah.
this is Guillermo. I got a quick question. So how many of your customers decide to just stick with the AWS objects when it comes to, routers, gateways, and firewalls? And so how many decide to go Cisco, Palo Alto, whatever, do third party?
Yep. So it's a fair question. It's a little bit nuanced. For the longest time, so I've been doing AWS for probably 6 or 7 years now. And until 2019, you didn't really have much option. You had to go with third-party routing products, I think. In very late 2018, I suppose, but really 2019 before anyone used it, AWS finally introduced a gateway product that was a little more scalable and reasonable called the Transit Gateway. So I have a lot of accounts that still use third-party routers, but I don't have any accounts that are still deploying third-party routers. I just have accounts that haven't moved away from their third-party routers, with a couple of caveats, one being SD-WAN. If you have SD-WAN, you probably do have some third-party routers, but that's a little bit more advanced kind of design where you probably have like an SD-WAN VPC that then ties into your transit gateway or something like that, or you may use a cloud-ready SD-WAN solution like Aviatrix or something like that. So there's a couple of advanced use cases that kind of get pretty complicated. We definitely don't have time for. But what I find is if someone's starting their AWS journey today or in the last, say, year and a half, they don't go with third-party routers very often because the transit gateway got rid of a lot of the need for that. If they've been in AWS for a while, like predating the transit gateway launch, then they almost certainly have third-party routers because there's other limitations like we'll talk about this with VPC Peering, but no transitive routing. So if I have 3 VPCs, VPC A is connected to VPC B, VPC B is connected to VPC C. A can route to B, B can route to C, but it turns out A cannot route to C through B. We just take that for granted with a regular router, that as long as they don't write a filter or anything. Transitive routing, that's the whole point of routing. but in AWS, transitive routing never worked until they launched the transit gateway. Hopefully that answers the question, Guillermo. It's a little bit nuanced. It's a straightforward question. It's just historically got a little bit more complex answer. Great. I see the thumbs up. Thank you. Okay, let's talk about security a little bit. And I think I mentioned this before, but we're just barely going to touch on security. So when we talk about the VPC itself, we've got just a handful of security mechanisms within the VPC. We've got something called network access control lists, or NACLs. We have something called security groups, and we have something called flow logs. I'll deal with flow logs first. Flow logs are literally logs of what came, went, and happened within your VPC at the packet level. If you turn on flow logs, which can be very helpful, you need to be aware that those logs, they need to go somewhere. It's not like that you turn on the logs and they're just running in the VPC and you pull them up in the console. You need to point the logs to go somewhere. So would that be like NetFlow? It's a little bit like NetFlow, Charlie, but it's not NetFlow in terms of being as a protocol or anything like that. It's got more data than just NetFlow, and then it has less application specificity than NetFlow. So it's kind of quasi-NetFlow-ish. And they can be used for application things, but they're mostly used for security. And yeah, you don't need a collector like a NetFlow collector. You just need a place to store the logs. The two common ones would be something called Cloudwatch, which is like a monitoring service in AWS. More commonly, it would be an S3 bucket, which is just an object storage container in AWS. And you may just throw your flow logs in there and then write an app that maybe parses through them, or utilize an AWS service to parse through them. The next one would be NACLs. S3 bucket is an object storage item. It's just, think of it as a folder where you could store different things. They call them buckets instead of folders, but it's object storage. It's not there for, you can't put an operating system in there or something like that, but you could put a file in there, and really a log at the end of the day is just a file, right? And so any file or object, what they call object, can go into S3 for storage. Yeah, I mean, there's a lot more to storage than just that. I'm not covering storage tonight, but S3 is a pretty common storage mechanism. There's other ones, EFS, EBS, etc. But S3 you could think of it as like a Windows share that you could dump all your logs into or something. NACLs or network access control lists they're just like access control list like we would see in a Cisco. They are attached at the subnet level. So they can filter traffic in and out of a subnet, but they cannot control any traffic within a subnet, right? You actually attach the NACL to the subnet object, and it's kind of a gatekeeper for what goes in and out of the subnet, but it does not inspect any traffic within the subnet, right? NACLs are not stateful, so you need to put rules in two directions, right? If you permit traffic out, you need to permit traffic back in. There's a default NACL that's created, which is permit any, by the way. If you want to use NACLs as a way to stop or secure traffic, you need to use something other than that default permit any NACL. Probably the most common security mechanism I find at the VPC or network level are security groups. And security groups attach to something called an ENI, or Elastic Network Interface. You could think of that as a VNIC. It's just the NIC that's on your VM. And the things that we're creating up there are effectively VMs. We call them EC2s. But the security group is attached to that VNIC. And because it attaches to the VNIC, the security group is much more granular. It can control traffic not at the subnet level, but at the VNIC level, right? And you cannot launch something in AWS like a server without associating a security group to it, right? So unlike NACLs where the default is permit any, you know, security groups actually have to be created and they have an implicit deny all. So you need to put some permit statements in there or all traffic is denied by default. Security groups, unlike NACLs, are stateful. So if I allow traffic in one direction, I do not need to make an allowance for the return traffic. They are stateful and they inspect the traffic coming in and out of the NIC in a stateful manner. Does that make sense? Any questions? Yes, that is correct. They are attached to the VNIC, which is really called an ENI. I should point out, I should have pointed this out maybe a little bit earlier. A lot of the concepts we're covering, they would work in other clouds as well, conceptually. Like if you look at Azure, they don't have VPCs, but they have VNets. A VNet is really just a VPC, right? It's just in Azure. So the nomenclature might change and some of the specific details might change, but the conceptually, what the basics, what we've covered here is the basics. They're pretty similar when you move from cloud to cloud. Same thing if you move to GCP. Okay, I just wanted to check the chat. Looks like I'm up to speed on the questions. So let's take a look. So compute, as I mentioned, we're getting ready to do our demo. So the basic unit of compute is called EC2, which just stands for Elastic Cloud Compute. It's effectively a VM. I mean, they don't call them VMs, they call them EC2s, but, and there are other things that you can launch that have compute capacity within them. But to keep this at the basics and the simple level, we're just going to talk about EC2s, right? And when you launch an EC2, it has to have at least one ENI, but it can have more than a single ENI. This makes sense, what I'm about to say, if you think about it, but it might not be obvious at first blush. And that is, if I have an EC2 and I launch it and it's in a specific availability zone, I've launched this EC2 over here and it's in AZ2. All of his ENIs, they need to be in the same AZ. They could be in a different subnet because you could have multiple subnets in an AZ, but all the ENIs need to be in the same AZ. If you think about it, that makes a lot of sense. Otherwise, you could have something like an outage in an AZ, but an ENI in a different AZ that's still up, which wouldn't make a lot of sense, right? ENIs are pretty much always addressed from DHCP in the VPC itself. They tend to have permanent leases on their DHCP, so it's not like they're changing IPs all the time. If you want that ENI to communicate to the internet through your IGW, obviously you're going to need a public IP. Remember I mentioned that there's a NAT function that goes with the IGW, right? And so there's a couple of ways to assign public IPs. One is when you create the EC2, you have the option to select something called auto assign. So I know, Charlie, you're looking for best practices. I recommend you do not use auto assign on the EC2s. The only time that you can enable auto assign is at instance instantiation. You can never do it after the fact. And it's also like a DHCP service. So if you stop, reboot, terminate, and restore, or anything like that, your public IP will change, which may mean that your security groups and things like that need to change as well, right? Or DNS records if you're hosting like a public website or something like that. So auto assign works really well if you're just if you're just spinning something up and kind of playing around a little bit. But if you're going into production, I don't recommend auto assign. The other option is called Elastic IP. This is what we'll do in our demo tonight. And an Elastic IP is just a static one-to-one NAT, which can be attached and detached from a specific ENI, right? So I can create a one-to-one NAT. That NAT actually, it turns out, lives on the IGW, but you view it over on the networking tab of your EC2. But it's actually a NAT that's over here on the IGW, right? So these public IPs are typically provided by Amazon themselves. I believe that you can now use your own public IPs. I've never done that, but I think you can, but it does require some paperwork to be able to route, for them to be able to route your IPs or something like that. So I'm not really certain on the specifics there. We had a question there. If you own some public IP, how do you assign it to AWS? Yeah, that's what I was just talking about, Charlie. I've never done that. I think there's some paperwork where you have to transfer some of, not the ownership per se, but you have to file some paperwork to let Amazon originate those on your behalf. I don't think it's very common, but I believe it was not supported for the longest time, but I think they did start supporting it somewhat recently, and I've never done it, to be just perfectly honest. So there is another more advanced NAT method we'll kind of get to in a little bit. But for tonight's demo, we're going to be using the Elastic IP. I will show you where the auto assign option is at, by the way. And so now we're going to switch over to the demo. Let me just get over here real quick. Can everyone still see my screen okay?
Yep.
Okay, perfect. So I've already logged into the console, so you don't have to watch me log in and fumble around with my MFA and everything else, right? And we're just going to go kind of similar to what we did in the slides. We're going to start with the VPC. I've got these as recently visited services, but if you had never logged in to the AWS console, you wouldn't have any recently visited services. It would look more like this, where it's just a blank canvas, and you would just click the down arrow on services, right? And you would scroll down until you found what you wanted, or you could just search up here if you wanted, and I could type in VPC, and it's smart enough to go find it, and I can pull it up. Now, I think I mentioned this kind of towards the beginning. Everything we're doing tonight is going to be done in the Oregon region. If you wanted to change regions, you just do it here, right? Here's all the different regions that they have. But we're going to stick in Oregon. So this is my VPC menu. I can come over and take a look at my VPCs. This is that default VPC I mentioned, right? And again, when you first create your AWS account, you're going to have a default VPC that's auto created for you in every single region. They all have overlapping IP space. They all use the same CIDR block, 172.31.0.0/16. That's already pre-subnetted for you. It's already got a routing table. It's already got an internet gateway. It has all those things. And I'm recommending you don't use it. So we're going to go ahead and create a VPC. So I find it's a lot easier if you always provide a name to all the things you create. And, you know, I'm going to come up with really obvious names tonight, but you should really think through what names make sense for your particular organization, right? So you can see that I've named it. I've given it a CIDR block. I'm not enabling IPv6. This tenancy, it usually would stay to default. The other option is dedicated. Dedicated means you cannot launch any services in that VPC unless they're on dedicated hardware, which is a pretty expensive way to do things. So with very few exceptions, you always want the tenancy to be default. You can still put dedicated hardware into a default tenancy VPC. It's just that if you pick a dedicated VPC, you cannot put anything other than dedicated hardware in there. You should probably get used to tagging all of your things. The main tag that you always want to have at a minimum is name with a capital N and then whatever you want to name it. You can see this was auto-populated from when I filled this in up here. It would be great if every AWS resource, when it asked you for a name up here, actually put it in as a key value pair down here. They're just not that consistent with it. So if you see a tag option and there is no key value pair for name in the key, then you will probably want to add it. And you could just do that by adding a new tag. So there we go. I've created my VPC. It's got my CIDR block, right? If I wanted to copy that VPC ID, I could just click it and copy that, right? I come into my subnets. Do I have any subnets in my CIDR block? I don't have any subnets in my CIDR block. So Guillermo asked, why are tags important? So tags are important. You could think, well, that name tag, capital N name, I think that's important because it's like putting a host name on your router. You don't want all of your routers to say router, right? You want it to say something meaningful to your organization, right? LAX dash Office One or whatever host name you want. So I like to do the same thing as I like to put a name tag at a minimum. There's other more important reasons potentially to put a tag. You can write scripts and policies based on certain tag values. Like not an uncommon one is that you have to tag a cost center for anything you spin up that's going to cost money so that we know who to bill for that something that you spun up, right? And you might write a script that says, if, yeah, so I'm covering that right now, Guillermo. So if you write a script that says like, hey, every hour, I want you to go through all my VPCs and look for anything that does not have a cost center tag. And if it doesn't have a cost center tag, you can go ahead and delete that resource, right? So, um, so that's why how you're going to use tags is a little bit up to your organization. I'm just recommending that at a minimum you include the name tag just to make it easier to know what you created and what it was named. So now let's create a subnet. We need to create it in the new VPC, the XYZ Corp VPC that I created. We'll give that a name, XYZ Corp. And this is, we'll call this the public subnet. I can allow this wizard to pick any AZ it feels it wants to pick, or I can manually pick what AZ I want stuff to go into. So I'll go ahead and manually pick. I think that's more common. And then out of my /23 CIDR block, what do I want to make this particular VPC? We'll do 10.1.1.0/24. You can see here's the key value pair for the tag name tag. I'll create that subnet. And then I'll create a second subnet. XYZ for private subnet. We're not going to do public and private tonight. That's a longer demo for sure. But it's not an uncommon thing. If you just Google AWS VPC architecture, you'll see a million diagrams that have public and private subnets. Okay, so there I've got my subnets created. If I get rid of this filter and I put my VPC identifier in there, you can now see I've now filtered down to the subnet attached to the VPC I created earlier, right? And I can see that as well. If I come in here, I can see it's attached to the XYZ Corp VPC. We're going to skip down to the IGW. I'm going to create an IGW. XYZ Corp IGW. You can see the name tag. On the network stuff, these name tags kind of auto-populate, which is very nice. You're going to see when we get into some of the EC2 menus, they don't do that as well. So now I've created the IGW, but I haven't actually attached it to a VPC. So I came up here, I could click on attach to VPC, or under actions, I could click attach to VPC. They do the same thing. It'll say, okay, what VPC do you want to attach it to? A VPC can only have a single IGW. Keep in mind the IGW is highly available by default because the IGW is a VPC wide construct, meaning it already covers every AZ in the region by default, right? And it's highly scalable, right? So that's why you don't attach multiple. There's no point to it. So I attach. There's some other reasons why you don't, but. And now let's go into my route tables, and I'm going to create 2 route tables. So you can see a route table is already created, by the way, for XYZ Corp VPC, but you'll see it has that main tag. And remember I said, I don't like using the main route table. If we come in here to the main route table for that VPC, you'll see no subnets are associated with that route table explicitly. That means both subnets are associated with it implicitly, right? I don't like that behavior. I don't like the concept of implicitly, you know, affiliating a subnet with a route table that I haven't really done anything with. Also, if we go into this route table, you'll see it has no routes. The only route it has is the route to itself. It's a local CIDR block. It doesn't go anywhere. And I keep all my default route tables or main route tables that way. So I'll create a new one, and we'll call this XYZ Corp dash hub dash RTB. I'll affiliate it with that particular VPC. I'll create the route table. Now that I've created it, like I said, I like to explicitly associate my subnet. So I come into my subnet associations. I edit my subnet associations. This is the public routing table, so I will associate the public subnet. And it's nice when you can line up those names. So this is one reason why I recommend that name tag be kind of used pervasively, Guillermo, to your earlier question. And then we can even add a route in here, right? I have an IGW, so let's go ahead and do that. Here's my default route. You could type it in as well, but default always comes up by default, no pun intended. And remember I said you don't use an IP address as your next hop, instead you use an object. So the object we're going to use is an internet gateway. And there we go. I'll populate that. I'll save changes. Okay, let's just come back and kind of look at this real quick. So we created our VPC. Just come in real quick. So we've created our VPC. We've created a couple of subnets, right? We've created a route table. This is the main routing table, right? I should really, I guess, you know what I should do for completeness is I'll create a secondary routing table here. XYZ Corp private RTB. And what I'll do is I will then associate the private subnet with that, right? And I might not put any routes in here because these are private hosts. They shouldn't be going to and from the internet. It's an oversimplification of what we usually mean by a private host, but for right now, for demo purposes, we'll say that's what it is. And so that means no traffic can get in and out of this subnet other than traffic that might be in the VPC itself, right? So the internet cannot get to and from it. And we created an IGW or an internet gateway, and we attached it to our VPC. So the next thing we're going to want to do now that we're done with the VPCs is go create in EC2, right? So again, if I don't, here I could just click on that. I could just, if I'm doing this all net new, I might just type in EC2. And this is a common thing. If I click on this, look what happens. It changes my main window off of VPC and over to EC2. I might not like that because I might want both windows open at the same time, right? So if I don't like that behavior, what's probably a little more common is to just right click and open that in a new tab. And now I can go back and forth between my VPC window and my EC2 window. I find this to be by far the easiest way when I have to go through multiple windows and multiple services in AWS to be able to line stuff up. So I'm not constantly having to go relook something up or something like that. We're going to go ahead and launch an instance. And what you're going to do is you have all these different instances that you could pick, right? You're going to want one that says free tier eligible. And you could click this little box, free tier only, and it will filter out anything that's not free tier. So I almost always use the Amazon Linux 2 AMI for these kinds of demos. And you can see that the free tier eligible one is the T2 Micro. It has one vCPU, 1 gig of memory, and it has low to moderate network performance. That's why it's free. It can't do a lot, right? But it's a nice enough host for things like pinging and SSH.
So I got a question, Jason, since you mentioned
Yeah.
pinging and SSH. I guess the only way to really test your setup, right, is to have an EC2 instance. There is no router or no device for you to just jump in and say, okay, well, ping the internet or source from this interface or check your route. There's nothing you can log in. Your tool is going to be the EC2 instance that you create to test traffic to and from the internet or from whatever subnet or VPC if you're connecting to a VPC, right? There's no like router.
There is no, that's a very valid point. There is no route. That's why I talk about that intrinsic router. It's more like a routing service, not a router. You're absolutely right. If this is a Cisco router, I can log in. I can choose what interface to source my ping from. I could say how big the packets are. I could set a toss value. I can do all sorts of things. I can't do any of that in AWS. I would say 99.9% of the time, yeah, you're going to do it from an EC2. There are a few other options. You don't have to use an EC2. You might use something else. But 99.9% of the time for particularly network savvy folks, yeah, an EC2 is going to do the job best.
Okay.
Sorry, I saw a comment, but I missed it. No, it is pretty cool. I shouldn't say it's free. I'm going to give a link at the end, by the way. It's free up to a point. I think you get 750 hours of compute time per month or something like that. So it's not free kind of in perpetuity, right? There are limits, but and to be honest, sometimes when I'm doing cuts, particularly cuts out on the internet, before my cut, I'll spin up an EC2 that I can access for testing, like, hey, can I get to that website or whatever I'm doing, right? Or to give a target that I maybe can ping because I'm changing internet circuits or something like that, right? So these are my instance details. The first thing I need to do is select the VPC I want to launch this instance into. So I want to use it in that VPC I created. What subnet do I want? You can see I have both my private and my public. I want to be able to ping and SSH this from my office, so I'll pick the public subnet. Here's where that auto assign public IP is, and you can see it's disabled by default. You could enable it. If I do it though, like I said, that public IP, it can change when I reboot or shut down and restart an instance. So in general, I don't like using auto assign. The only time you can ever auto assign is at instantiation. You can never turn it on once you've done that. There's a whole bunch of other things. We're not going to do these right now. You can do things like user data means, do I have like a particular startup script I want on this EC2? Like maybe I want to run a yum update by default and I want to install an Apache web server or something like that. I could add in an additional ENI, right? I could protect my behavior from accidentally terminating an instance. This is all for a test environment. I don't do any of that advanced stuff typically in a test environment. If I delete something, it's okay. It's a test environment, right? If you were going to run production apps, a lot of these boxes you would spend more time on. And I'm just going to leave this as is, right? This is my root volume. It's 8 gigs in size. It's SSD though, which is kind of nice. I get, well, there's a complex amount of math that goes into number of IOPS that you kind of get. You'll see that the root volume is always deleted on termination by default. You could uncheck that and it would not delete the root volume. Typically, you do want to delete the root volume, and you could also encrypt it. We're not going to encrypt it, but you could. Add tags. So EC2s, they don't auto tag things, so you have to actually add in your tags. So here I'll add in name. I'll call it XYZ Corp Pub EC2 because I'm very creative with my names. Remember, you cannot launch an EC2 without a security group. It's a mandatory thing, right? You have to have a security group. So I could either create or I could select an existing. The only existing one is the default security group, which I believe will deny all traffic. So I'll create a new one and I'll give it a name. I'll call it XYZ Corp Pub SG. And I do want to SSH, but I probably don't want the whole internet to SSH to it. So I'll just lock it down to my IP. I may want to ping. I'll lock that down to my IP. And now it's going to say, hey, why don't you review this information, make sure it looks okay, right? And then launch. So it's important that you realize that you're going to need a key pair. I'm not going to create a new key pair. I've already got a key pair. If this was your very first time spinning up something in a region, you would select, or it would select for you, create a new key pair because it would notice you don't have any key pairs. I already have a key pair in this region, so I'm just going to go ahead and say I acknowledge that I do have that key pair. And it's kind of that simple, right? It'll take a few minutes, but it's going to start spinning up my instance. If I come in here, you can see it's still kind of everything's pending. I literally just hit submit. It'll take a minute, right? And if you click into the instance, one of the things that's nice is you have these details down here. It'll tell you things like the security. It'll tell you things like what security group you're in, what the security group roles are. If you have a particular IAM policy attached to it or role attached to it. In the networking, you can see things like what the IP address is. You can see my IP address. My private IP address is this, right? Etc. You can see your storage, all those sorts of things. And you can see that now my instance is running. It is up and running. It's still doing some status checks to make sure that that the hypervisor can reach it and different things like that. But the actual instance itself is running. So real quick question, can I ping and SSH to this instance yet, do you think? Anyone got some guesses? Okay. The answer is no. Okay, yeah, Ben says no. Yeah, no is correct because my only IP address is a private IP, right? There's no way out on the internet for me. Um, there's no way from, across the internet for me to get to a 10.1.1.236 address, right? I could try all day.
Didn't
It's
you
not going to
set
get
up
very
your
far.
own address at one point to be accessible?
That was a source IP. I said I only want to allow ping and SSH from my source IP, but I don't have a public IP on this end yet. I've only got a private IP. So we're going to go create that public IP now. If I scroll down, you'll see where it says Elastic IPs. And the first step is to allocate one, right? It'll say, hey, what region are you going to be in? Here you can see I'm just defaulting to an Amazon public IP. There are options for you to use your own customer-owned IPs. Again, I've never done this, but it's going to involve some paperwork and working with Amazon. You'll see that there is no name. Again, in the EC2, they're not very good about that, so I just add in a tag. I call it name, and I might call it something like XYZ Orp pub EIP. Maybe pub's implied. No need for Elastic IP if I'm not a public. So maybe I just call it XYZ Corp EIP. I allocate it. That just creates the IP. It's not actually associated with anything yet. So then I come in, I can either click the down arrow here and associate, or I could click up here and associate. And this is not going to be important for our specific lab, but it's important in general. You could associate it with an instance, which makes sense if that instance has only one ENI. However, if an instance has multiple ENIs, think about an ASA firewall. It might have an ENI for the untrust and an ENI for the trust. Well, you might want to assign this public IP only to the untrust. I probably don't want a public IP on my inside interface, right? In our case, we only have a single ENI. So I only have one instance. I could manually tag it to this. You don't have to do these things though. You can see I can also just leave them blank. It'll work. And then I associate this, right? And we can see this is my IP address. So now if I try to ping this IP, do we think I can ping it? Any guesses?
Probably okay at this point.
As long as I didn't do anything wrong. And it looks like I didn't. Okay. So yeah, I can ping this. And now if I wanted to SSH in, yeah, there we go. Now I can obviously get to it from the internet. Can it get back out to the internet?
One would hope so.
It looks like it can. So, um, and so that's really it. We can, there we go. Yeah, stateful. There you go. So the stateful, while that's true, remember that the security group I created only allows in and out my IP. So that means that kind of implies there must be a different security group for the outbound traffic. And so I'm glad you brought up stateful. I'll show you what that looks like now. The default security group for outbound is permit any. If we come down here And here we can see this is my security group that we're looking at right now, right? XYZ Corp Pub SG. I have my inbound rules. Those are tied to my specific source IP. My outbound rules, this is just default, permit all, right? To anywhere. You can absolutely change this. And depending on your app and your security requirements, you may want to change it. A lot of people don't change the outbound. Instead, they strictly control the inbound. So, and that's really it for the demo. I'll switch back to the slides to go through the advanced networking. But are there any questions before I switch back that were specific to the demo itself? Did this make sense? Is this helpful or useful?
So when you've got the computing instance there, is there a since it's the free one available, without any extra charge, is there a version of Linux that it would be akin to?
It's a AWS Linux, and I can't remember what it's based on, CentOS or something like that. But it's kind of an Amazon distribution that they kind of created. There are other free ones. I think that there may be. I think that there's a SUSE Linux that's free tier eligible. I think that there's a Ubuntu free Linux. I go with the Amazon ones for a couple reasons. Number one, pure laziness. Um, uh, it's the first one in the list. The
I
other
can
thing
respect
is,
that.
yeah, the other one though is, let me just show you real quick. Maybe this is easier. I'm not actually going to spin it up. I'm just going to go into the menu. The Amazon Linux AMIs, they come built in with Amazon tools like the AWS CLI and stuff like that on them. And so there are some tools I'm not using tonight, but there are sometimes some tools like for accessing the CLI and stuff like that of the AWS console that I like to have access to. So I also like the AWS AMI because those all come kind of pre-installed. So, and the one thing, I'm not going to go through this right now. You're just going to have to take my word for it that I'll do it later. But to stay within the free tier, again, I only get 750 hours a month, only in air quotes, because that's a lot of time, right? But when I'm done with the demo and everything and we all log off of the WebEx, I will go in and delete everything. And when you're first, if there's one piece of advice I have for you and you're interested in learning more about Amazon, it's when you're first starting out, get used to doing all this stuff manually. This doesn't apply to you as much if you're already a developer and you already have developer skills. But as a network engineer or a network architect that's trying to learn how to do cloud networking, which is already different enough, do it manual and do it again and again and again. And once you're really comfortable doing it and you've learned all your lessons, then yeah, go all in. Go learn how to do it via the CLI or something like that, right? Um, you can pull up a tab and run it in the Cloud Shell CLI or something like that. So let's come back to the slides now. And we're wrapping up not just a few of these advanced networking topics, but these are things I cannot easily or reasonably demo. But I think that they're important because they tell you a lot more about how you might want to connect your enterprise to a cloud. And remember, everything I've talked about, while the nomenclature might change, conceptually, it would be the same or similar, at least in Azure or Google Cloud, probably other clouds as well. I'm really only familiar with the three. And of those three, I'm 99.99% familiar with AWS and 0.001% familiar with Azure and 0.000, not one with GCP. So, but these concepts are pretty universal conceptually, different terms.
So
The first,
when you talk
yeah,
about this, the CLI, would it be using like a shell scripting type of arrangement or
yes, yeah, something like that. Yeah, it's I'm definitely not demoing that tonight because I don't have anything ready for that. But
so
yeah, it's more like a PowerShell sort of thing, and you go in and you can call objects through the APIs. You can integrate it with programming languages and address things through different data types and stuff like that. And it's far more efficient if you're comfortable in that vernacular. But when you're first starting out, especially if you don't already have a programming background, I find that the console is easier and quicker to learn. But once you're familiar with the console, it's kind of nice to do things through the ACI because it's much more efficient. Does that answer your question, Charlie?
yeah, because I imagine if you're
Okay.
doing Azure, then it's totally PowerShell, but you
It
know,
is.
for the other
They
two,
have a
it's probably variations of Unix.
you can install the AWS CLI on Windows, Linux, or Mac. Google, I'm not sure, to be honest, but probably the same. But for sure, the AWS CLI, they've got a distribution for all the main OSs. So, and you would just access it through Windows PowerShell or even just Windows command prompt. And I'm not a Mac person, so I couldn't tell you, but you do it on there as well. So the first item on advanced networking would be direct connects. And this is kind of what it sounds like. It's a direct private dark fiber circuit between your routing device and AWS. Okay. So maybe you've got a data center and that data center may provide direct connect services into AWS. You would just order the direct connect circuit through the AWS console. They would run the fiber over to your cage. You would plug in the optics, hook it up. The direct connect supports BGP or static routing. In my experience, you typically want to do BGP. It is limited on BGP. If you're really into AWS, I recommend you attend at least the free version of AWS reInvent after Thanksgiving. I've been told there may be some announcements for enhanced BGP support on the Direct Connect service, although I don't know that for a fact. I've heard some hints. And then you're going to configure something called a virtual interface. This is how you're going to peer your BGP. It could be private, public, or transit. A private a private virtual interface ties to something called a VGW. We're going to talk about that in a slide or two. A public virtual interface ties to the AWS public backbone. You would use that if you're trying to address like a lot of data transfer to a public AWS service like S3, for example, or CloudFront potentially, or something like that. And the transit virtual interface, or VIF, that connects to something called a TGW, which we'll talk about in a few slides. So along with Direct Connects, there's a concept of Direct Connect Gateway. The Direct Connect circuits themselves, because they are dark fiber between you and AWS, they're regional, right? So I order Direct Connect circuits in Oregon or in Virginia or in Frankfurt, Germany or London, right? Or wherever. And that's where those circuits are, right? But it might be nice to be able to utilize those direct connect circuits for multiple regions, right? And so a direct connect gateway allows you to do that. It allows you to tie other regions into your direct connect service. So if I had one data center that's in Texas, and I had direct connect circuits there, I could tie them into a direct connect gateway and then tie the direct connect gateway to both the Virginia and the Oregon region from Texas, for example, right? I mean, you're still going to have latency if you go between the two or something like that, but it still can be a nice way to get more utilization out of your direct connect circuits instead of pulling them to every single data center you have. Private virtual gateway. So what the IGW does for internet access, the VGW does for private access. So what a VGW does is it terminates IPsec tunnels from your routing device. That could be a firewall, that could be a router, it could be a Linux box if you want, whatever. But you would tie an IPsec tunnel between your on-prem to the VGW, and then this allows you to talk directly to your private IP space. Now I don't need any NATs because this is like a site-to-site VPN that hooks up two private networks together, right? So the VGW, and I don't know why it's called a VGW, but it's a private virtual gateway. To me, it should be called a PVG, but it's called a VGW. But anyway, it's kind of how you would do private communication between your on-prem and your VPC. Was there a question? Sorry.
So this gets you to your hybrid space where when you're transitioning through, you've got your existing data center and you can connect it up to
You
your
can.
cloud space here.
Yeah, you can. There's a couple of important caveats or limitations. The VGW does support BGP, which is kind of nice, but the VGW shares its route table with the intrinsic router. And remember that there's a hard limit of 100 routes on that intrinsic router. So if you've got 1,000 routes in your network, you can't just send those up to your VGW. It will crash your entire VPC. Doesn't crash the VPC. What it really does is it crashes this intrinsic router. Basically, when the intrinsic router gets to route 101, it freezes the BGP process on the intrinsic router and flushes all the routes. Then it brings BGP back up. It starts accepting routes. When it gets to 101, it freezes it, restarts it, and you just get into a cycle. And it effectively makes it so that nothing in your VPC can talk, not even between two subnets directly in the VPC.
So you got to
So
do a lot of summarization.
you got to be very careful. A lot of times people just send a default route up there and bring the internet back down. But you could also do something like, hey, on this end, I've got 10/8 or something like that, right? Or, yes, some kind of summarization, however you're going to do it. And the encrypted throughput on this VGW is capped at 1.25 gigabits per second, which is fine. If you've got like a 200 meg circuit at your office, then who cares? I've got a lot of accounts that they have 10 gig WANs, and so this is a massive problem for them, right? This is not very scalable if you're used to having very high WAN bandwidth. So you can get around that with something called the TGW that we'll look at shortly. But just be aware there are some caveats with this VGW. VPC peering. So if I have two VPCs that are in a region, now I've got my 10.1.0.0/23, and I create a second VPC, 10.1.2.0/23, and I decide I want these two VPCs to talk to each other. There's a question of how do I tie them together? And there's a couple of ways to do this, to be honest. One of the ways is through something called VPC peering. And what happens with the VPC peering is it allows you to put a route table entry that points to a particular type of object called a peering endpoint. And I'll say, hey, up here in this VPC, if you want to get to 10.1.2.0, point it to the peer, right? And that's an object. And that object knows, hey, okay, it goes over here, right? And it's happening kind of in the underlay of AWS. And down here, likewise, I say, hey, if you want to get to 10.1. Oh, this is backwards. I copied and pasted the route table. That's embarrassing. The route table down here should read, if you want to get to 10.1.0.0/23, you go to the peer as well, right? Peers do not support transitive routing. So if I added a third VPC over here, kind of to the right of this VPC, I could set up peering from this VPC to this VPC and it would work, and this VPC to this VPC and it would work, but I could never peer to this VPC over here through this VPC. I have to build a second peering that goes from this VPC to this VPC directly. So transitive routing, not very scalable with VPC peering. Just don't do it, I guess. And you can do these within the same region or across regions. It's very nice that you can do this across regions for certain HA functions and things like that, or possibly because you're trying to move a lot of data from one region to another for one reason or another. And next is the Transit Gateway. This is what I mentioned. I think this launched in late 2018, really kind of caught on in 2019. And this does do transitive routing. And this is a much more effective way to peer your VPCs than VPC peering. But with a caveat, this is relatively cheap. This is relatively expensive, but it's way more scalable and flexible. Okay. The TGW can scale up to 50 gigabits of throughput as opposed to that 1.25 gigabits that we had before on like the VGW, and I believe 1.25 is the limit on a VPC peer as well. It supports 5,000 routes instead of 100 routes. It supports a concept similar to VRFs. It supports BGP over IPsec. So instead of peering to that VGW and being limited to 1.25 gigabits, I could peer to my transit gateway and get greater throughput. Now, per IPsec tunnel, you still have a 1.25 gigabit per second limitation at IPsec level. However, you can build multiple tunnels to the TGW and scale up your bandwidth that way. And this is an all native AWS creation. You don't need any third-party routing. So Guillermo, to your question earlier, back when this was the most efficient way to peer to VPCs, I used third-party routing all the time. In fact, in 2017 or 2018, I gave a whole talk at Cisco Live in Orlando on how to use the CSRs for transitive routing in AWS. But by the time that the TGW came out, that no longer really became super valid because it was much more scalable to do it without the third party. There are still some cases like SD-WAN where that third party makes a lot of sense, but it just depends on your use case a little bit. I think this is the last one, which is the NAT gateway. So if you wanted to be able to do a lot of NATs, that elastic IP becomes kind of inefficient because it's a one-to-one NAT mechanism, and you pay per elastic IP and per gigabyte through the elastic IP that gets NATed. So it becomes fairly inefficient and not very scalable in terms of cost to just assign elastic IPs to everything. You can create something called a NAT gateway, which is like a one-to-many NAT or NAT overload or whatever you want to call it. And in this case, what happens is the NAT gateway gets an elastic IP, and it allows, it's a one-way gate. It allows internet traffic to leave your VPC going to the internet, but the internet cannot initiate traffic into your VPC through a NAT gateway. So that public IP, that elastic IP on the NAT gateway, it will allow return traffic, but it will never allow public traffic to initiate in through that public IP. You can still have other things in your public subnet that do allow the internet to initiate in, like we demoed earlier, but the net gateway won't fulfill that. But the net gateway allows you to do a one-to-many NAT sort of thing. So I could have thousands of hosts back here in my private subnet that all go out as a single public IP for things like patching or web browsing or whatever, right? One thing on the NAT gateway is it's an availability zone level construct. So it's in one and only one AZ. It's highly resilient within that AZ. So it's actually a cluster of devices. It's not like a single device in a rack or something. It's a cluster of devices, but it isn't a single AZ. AWS doesn't have a lot of AZ outages, but they're not impossible. They do have them occasionally. So if you wanted something to be highly available, you would actually create maybe a second public subnet and put a second NAT gateway in there. That really just comes down to your particular business and what your business can tolerate in terms of cost versus redundancy, right? So just be aware of that. That's it for advanced networking. There's a million other advanced networking things we didn't go into, like, we didn't talk through load balancers or DNS or any of that stuff. Again, you could spend 40 hours just going through networking and still not cover everything, right? This is just meant to give you a taste of what's out there. So these will go up on the SCUG site. It usually takes 3 or 4 days, and then this video will also go up on the SCUG website and on YouTube under the LA Networks channel. I don't know the timing on that, probably within a week. So, but if you are interested in creating a free tier account, I recommend you go to this link and read about what the free tier account is, because not everything is free in perpetuity. I tend to create a brand new AWS account every year and create a new free tier account because a lot of things are free for 1 year. And I'm not interested in paying for it. So I just delete my old account and create a new one in January pretty much every year. Remember that in networking, we usually avoid most default objects like the default VPC or the main routing table and instead create our own. Remember that most routing in AWS is more like a routing service, and be aware of things like scalability limits, okay? With your instances, you probably want to try to avoid starting and stopping within the same hour on an instance because this does not apply to free tier, but when you're doing stuff in production, you could end up being charged for the entire hour, so you might as well use the entire hour, right? It depends a little bit on the instance type. When you're first getting started, you can actually create a Cloudwatch Alarm for free that warns you when there's spending, right? So I actually have one of these, and it says, hey, if you incur more than $5 of expense on your account, send an email alert to my email account, right? Which makes sense. So I've gotten 2 bills in the last. I guess I've been doing free tier for about 4 years. I've gotten 2 bills in that time. One was, I think, for like around 70 cents, and one was for like $1.10. So I've gotten an awful lot of AWS experience with paying very little money for the AWS itself. The fact that they give you access to this free tier to me is pretty amazing. We didn't go into S3 very much. I mentioned that it's a file storage or object storage item. They are, you can make an S3 bucket, which is kind of, again, like a folder. You could make it public, but it's difficult to make it public for a reason. You typically do not want to make your S3 buckets public. There could be a use case to making them public, but don't do it unless you understand why you might want to do it. And that's it. I know we went pretty late tonight. It was a lot of material though, and it included a demo. Hopefully everyone got something out of it, and hopefully I answered most of the questions. Did anyone have any other questions? Thanks, Charlie. Thanks, Scott. Okay.
A great class.
Yeah. Oh, look at that. We got really good turnout. A couple people came in when I wasn't looking. So, just as a reminder, if you go to scug.net by next week, the slides and recording should be up there. And if you do have questions or you're getting kind of into AWS and you would like to know a little bit more, you can reach out to me or someone else in my company if you would like. You know, la-networks.com is our website, and we can chat and see if it makes sense to do a consulting engagement or maybe just a quick lunch and learn to go through this a little more in depth or something like that. Okay. Next month, just as a reminder, we're doing a big we're doing infrastructure as code, and we're trying to drive up demand and see if we could get some new faces. It's kind of great to actually see even this many people on one of these meetings. We used to get a lot more people than this, and we're trying to get people back in. So if you know anyone who you think might enjoy this kind of training, we're going to be doing infrastructure as code next month, and should be a pretty good time. One of the speaker that month works actually for Robert, so I think he should be pretty good, bring a lot of knowledge. And if you know someone who you think might benefit from that or any of these talks, please go ahead and pass the word. I mean, we never collect dues or anything like this. We've been doing this for, I guess, over 22 years now, Robert and I. So it's really just trying to get the word out there and that there's good free training for engineers. So please feel free to pass the word along. That's it, everyone. I've kept you long enough, and I'm actually still at work in the office. It's time for me to get going. So,
Oh my gosh.
thanks so much for your time, everyone. Have a great evening.
Thank you,
Thank you,
Jason.
Jason.
See you around.
Bye-bye.
Bye now.
Thanks, Jason.
Well,
Thanks,
thank
Robert.
you.
Have a good evening.
All right.